Excel has two different sets of functions for dealing with normal distributions. One set assumes that you're working with a standard normal distribution, and the other works for any distribution, any normal distribution. So in your head, the key distinction you want to keep in mind is are you given a z-score, which would mean you're working with the standard normal distribution formulas, or do you have an actual data value, a height or a weight or a test score? And in that case, you're also going to need to know the mean and standard deviation of your population. Right? In that case, you're going to use I'm calling it here other normal distribution formulas. So I've set Excel up here so that it's going to show the formulas that I type rather than their values. All right, so you'll be able to see the formulas all the time. So there's two primary questions you're going to get asked about normal distributions. One is finding a probability. For example, you're given a z-score and you want to find the probability of getting a result less than that value. All right, well, to do that, you're going to go into my formula here. I'm going to do NORM for normal dot S. Right, that's the key difference between the two sets of formulas. If you have this dot S in the formula's name, that's for a standard normal distribution. And to get probabilities, you're going to use the DIST, the distribution function. And you see it's prompting me here. It wants my z-score. I'm going to give it 0. Right? And when you're looking for probabilities, like what you're calculating in a standard introductory statistics class, this cumulative value is always going to be true. True says I want you to add up. That's the cumulative part. I want you to add up all of the values below my z-score. Right? So there's my formula. All right, and now I'm going to switch this back here for a second so you can see what it calculates. And if you think about this for a minute, you should know what this value is going to be, right? 0 is the mean of a standard normal distribution. So what I'm asking it is, what is the probability of getting a result less than the mean? Well, that should be 0.5, right? Because the distribution is symmetric. Half of it is below the mean, half of it is above. So real quickly here, I'm going to tell it to stop showing me the formulas. And you see, yeah, we do get the value we the value we expected at 0.5. So what if you want other things? Like, for example, excuse me, what if you want the probability of a value greater than your z-score? Well, if you want anything other than a less than, you have to use what you know about probabilities, right? To do a greater than, I'm going to do 1 minus the probability of getting less than that value. And we have our formula here for getting a less than. Right. Similarly, if you wanted to do a between, you know how we do a between probability? You find the probabilities of the two individual values and subtract them. You would have to do the same thing here. All right, now let's jump over here. And let's say we want to ask the same questions, but now we don't have a z-score. We have a data value. For example, we have a specific height or a specific weight. Well, Excel will do these as well, right? To do these, we're going to use almost the same function. I'm going to do norm.dist. Notice that I left out the S, right? And when I do the open parentheses here, it's going to ask me for two additional values, right? Now, in addition to the X value, notice it's X, not Z, right? Because we use X for data values, Z for z-scores. Now it wants both the data value, the mean, the standard deviation, and again that cumulative parameter. So let's say, just for testing here, I'm going to give it 100, and I'm going to make the mean 100. So you see, I'm really asking the same question here. I'm asking, what is the probability of getting a result less than the mean? And the standard deviation really shouldn't matter, but you have to put a number in. Now, this should also give me 0.5, and yes, it does, right? something I'll do sometimes if I'm a little unsure about a formula. Enter values that you know what the result should be, and use that to kind of test and make sure you're using the formula correctly. Right, and again, if you want to do greater than probabilities, less than probabilities, you're going to use the exact same methods here with this formula. All right, now the other direction, right, the other question you can get asked sometimes with these normal distributions is you're given a probability and you want to find a z-score, right? So here we want to find a z-score, not a probability. Well, Excel will do this for you as well. With a normal distribution, I'm going to do norm.s.inv for inverse, right? This is kind of, think of it as going the other way. And I'm going to open parentheses. See, it's asking for a probability, right? So I can test this the same way. If I put 0.5 for my probability, this should come out to the mean, which for a standard normal distribution is 0. And you see, yeah, that is the value that I get here. Okay, and over here on the other normal distributions, we can do it here as well. It's going to look really identical, right? It's going to be the same formula, but without the S. So I'm going to do INV, and we can run the same test here. Let's say 0.5. We'll give it a mean of 100 and a standard deviation of 10. Standard deviation shouldn't make a difference here. The value that will give me a probability of 1/2 should be the mean, which I told it is 100. And if we check the formulas, whoops, went too quick. There we go. If we check the results, yeah, that is the value that we're getting. All right, so these are really the 4 main formulas that you're going to use all the time, especially in an introductory statistics class. The key thing that I really want you to keep in mind here, because when we talk later on in another lecture about other distributions like t-distributions, chi-square distributions, they're going to follow the same pattern. You're going to have something like this norm, some abbreviation for the name of the distribution. And if you want a probability, you're going to put that abbreviated name .dist. And if you want a t-score, a chi-square score, you're going to do that abbreviated name .inv. So just across the board, just kind of summarize here, this dist is always going to give you a probability, and inv is always going to give you a something score, t-score, z-score, whatever the distribution is. All right, now if I go in here again and I do norm dot, there we go. You see there are some others that look familiar down here. This norm dis, norm inverse, and the S's here. Those look like the ones we just used, only they're short some of those periods. All right, and I want you to notice the little symbol next to it. Maybe it's hard to see even sitting here. It's kind of small. It's a triangle with an exclamation point in it, right? It looks kind of like a yield symbol. That's a symbol that Excel uses for formulas that have been what's called deprecated. That's a software developer's term for a formula that you really shouldn't use anymore, right? These 4 with that little symbol have been replaced by these 4 up here, right? The ones that I was using here today. And there's a lot of reasons why this can happen. Maybe they're just trying to streamline and make all of the formula names consistent where they weren't before. Maybe the parameters have changed. All sorts of reasons why this can happen. But the developers, they don't want to just delete those old formulas from the program, because there are a lot of spreadsheets out there that still use them, right? They were used back in the old days, if you will. And those spreadsheets would all break if those formulas were just removed from the program altogether. So they're left there for what's called backward compatibility, but you should definitely avoid using them, because at some point, 2 reasons. First, they're not being developed. So if it turns out that there's a problem with them, there's a more than half decent chance that problem won't be fixed. And second, it's possible that at some point in the distant future, they may actually be removed. So Stay away from those. Only use the ones I talked about here with the periods, and you'll be in good shape.